Hello, I am Aruna Florence, research scholar from the School of Computer and Information Sciences, University of Hyderabad, Telangana, India. I am presenting a paper in Whispers Conference 2023. My title of the paper is Hyperspectral Image Classification using the Spectral and Spatial Dimension Reduction Methods. This is the outline of my presentation. Abstract, introduction, methodology, experiments with the dimension reduction method, conclusion and the future work. References. Before going to discuss about my problem, I want to elaborate what is hyperspectral image classification. Classification of hyperspectral images is difficult due to the high dimensionality arising from a large number of the spectral bands for the same spatial area. Classification of a spectral signature is an approach to identifying the land usage or the identification of objects like trees, buildings, etc. But there is a crisis of labeled data in hyperspectral image. In order to save overtraining time and avoid the overfitting, for accurate hyperspectral image classification, dimensionality reduction is required to extract the low dimensional features from the high dimensional hyperspectral images. To address this problem, we were solved by the spectral and the spatial reduction methods. We propose one new method usually based on the principal component analysis and the filters. Spectral dimensions are reduced by the SubXPCA and the spatial dimensions are reduced by the extended morphological profiles and perform the classification to classify the various hyperspectral objects in a scene. Depending on the availability of a label information, feature extraction approaches are divided into the supervised and unsupervised models. Principal component analysis is a well-known unsupervised dimensionality reduction algorithm. It aims the optimum linear projections by maximizing the variance. But temporal complexity of a classical PCA is really high. So this is avoided by using the SubPCA which chooses the features locally. And there is one more paper which chooses the intrapersonal subspace analysis. Subpatterns are going to be chosen. But SubXPCA uses the cross subpattern correlations. But it has three parts. In each first step, each pattern is divided into the smaller chunks. And in the second step, we were finding the cross subpattern correlationship. Third step, we were applying the classical PCA. Extended morphological profiles is applied to reduce the spatial dimensions. Morphological profile is the first start for the extended morphological profiles. It may be obtained the open profiles and the closed profiles. It removes the superfluous information and protecting the geometric information by using the dilation and the erosion operations. Morphological profile is a combination of different closed profiles and the open profiles. By extracting the morphological profile features from each channel of hyperspectral images, we will get the extended morphological features. First, we will apply the SubXPCA to reduce the spectral dimensions and then apply the extended morphological profiles to reduce the spatial dimensions. And these are the results we got after applying the dimension reduction on the classification by using the different classifiers: support vector emission, k-nearest neighbor, logistic regression, naive-based, decision tree, random forest, and extra trees. This is the table shows on the Indian Pine dataset. This table shows the classification accuracy on the Pavia University dataset. This table shows the classification accuracy on the Salinas dataset. And this is the ground truth of an Indian image dataset after applying the SVM classifier and logistic regression classifier, k-nearest neighbor classifier, Navi-Bayes classifier, random forest classifier, decision trees, and the extra trees. Conclusion of my paper is we get the very good classification accuracies using the dimension reduction methods. In future, we want to implement The spatial dimension reduction methods using the sparse representation are the low rank representations. And these are the few references we follow in our paper. Thank you.